Hi guys. The talk will be in English. I guess somebody here in the room only understands English, so that's why it's going to be convenient. There are not so many people in the room, so I'll not ask questions from you. I'll just tell that my experience tells me that not so many people actually put these technologies together to create integration testing. So that's why I will show you the tools, I'll give you the names, which you will be able to experiment with later in your projects. Yeah? Uh-huh.
So I've done a little bit of it.
But you don't use Liquibase?
No.
Okay. Yeah, so that's exactly my point. So people do use these technologies. They use Docker, they use Postgres, of course, Maven, but together with Liquibase and all that things, it's not really like typical setup, which I find quite convenient. I find this is really like useful, and I'll show you in production. I'll give you the production project, and we will try to make a integration test, and we will deploy it, and you will see how it all works. So it's going to be live coding, just a few slides. Hopefully it's going to work, but it's going to be live, so we'll try. So there's going to be the technologies. The Liquibase is an open source tool for maintaining changes in the database. Not the changes of the data, but changes of the model, of the structure of the database, of tables, columns, triggers, constraints, all that things. It is not only for Postgres, it's the tool which is useful for other databases like MySQL, Oracle, whatever you want. Maven is the build automation tool which is going to put all pieces together. Maven is the one which Java developers are using. Postgres, that's what the conference is about, that's the database. Everything I'll show you is about Postgres, but you can use something similar I have an experience using the same set of tools for MySQL. You can try for other databases as well. Java is the language, what we're going to see. I'm not going to show you a lot of Java. You don't need to be Java developer to understand the point. Router is my open source tool which will put Docker on top of everything we're going to discuss. So it's a tool which basically will start a Docker container, put everything there, and run the deployment to Heroku. So Heroku is going to be the production platform where everything will work. Heroku provides the platform for running Java code and Postgres as well. So we're going to use Java on Heroku plus Postgres on Heroku. So the production database is not my server. The server which I'm going to show you now is provided by Heroku. A little bit of theory, and then we'll go to practice. So Liquibase, this is how it works. Again, I'm not going to ask the question, but I believe that most people are not using this tool, which is a perfect tool for database management. If you are a database administrator, you must use it. There are some alternatives on the market, like Flyway, for example, which is a similar tool, which you can also try, but I tried that, I used that one. I find Liquibase more convenient. There is more support on the community, so I'm recommending to use Liquibase. This is how it works in a few words. So let's say you have the database, and the database has some model, some database schema, meaning tables, columns in the tables, constraints, triggers, and all that. So to create that table, we usually go like, we start a new project, we start it from scratch, we have an empty database, we create a table for Java developers. So if we are Java developers, we create a table for us. Then we alter the table. Then we create some other table. Then we add some column to the table. Then we drop some tables. So we are making changes to the database. We don't create the whole database from scratch and then keep it like that till the end of the project. It doesn't work like that. So usually we develop, we progress, the database evolves, the database grows together with the source code. We make changes to Java code, to Ruby code, to whatever code you have, to PHP code, and also you make changes to the database. So you need to add new columns, you need to create new tables, you need to develop. We have source code control like GitHub, like Git or SV and Subversion. We have that instruments to control versions of the code, but we don't have the same instrument from Postgres. Postgres does not provide us any tools to tell us what was the state of a database a month ago. We just don't know. All we have in Postgres is just what it is now. We just look at the database after the change number 5. We just look at it and we don't see the table X or whatever. It doesn't exist there, but it was there before. So we don't see how it happened. We don't know the history of the database changes. We just have the current situation of the database. That's how it was in the source code many years ago. People didn't have this Subversion or Git. They didn't have source control. They just had a piece of code, and many developers work like that as well. They just don't control versions. They just have a piece of code, and they just deploy it, that code, upload it somewhere, but they don't control versions. In the database, we want to control versions as well. We need it, but I don't know any databases which provide that version control, to my knowledge. They just don't have it. And that's why the Liquibase is there. That's why tools like Liquibase exist on the market, to provide us that instrument of control. So from now on, if we don't use the Liquibase, let's go back. If we don't use Liquibase, what we do, these database administrators, the developers, programmers, they just come to the database administrator and say, hey, I need a new table. Here's the structure of the table. And the database administrator creates the table. Or programmers, they have access to the database, they create the table. We just do it directly. We just go to the database and update the schema. We don't do it anymore like that. We put Liquibase in front of that. So Liquibase is a software tool which you run from the command line. You say Liquibase. It's Java. It's written in Java, so you start it from the command line, and you say, create a new table for me in the database. And the database goes to and the Liquibase goes to Postgres, creates the table for you, and records that change in the table called database change log. So Liquibase creates a special table in your database where all the changes are tracked. I'll show you now the content of this table. It's quite primitive. It's not a big deal. You can write this tool yourself in like a few weeks. But Liquibase is quite powerful. It allows you to do many things. But that's the core idea. You don't touch the database directly anymore. You don't open this Postgres administrator tools. You don't open the structure. You don't modify the table. All you do is you work locally. You touch your local database or test database, but you never go to production. You don't touch it there directly. All you do is you create special files. I'll show you that files now. And then you run Liquibase, and Liquibase updates your production database like that. So that's the core idea of writing tests. Why it's good? There are so many advantages of that approach, and it's really good for integration testing. When you start doing that, it's going to look like quite annoying in the beginning because you're used to updating the database directly. You're used to going just right there and changing something. When the database grows and the team is big, and then you will have many these files for Liquibase, it will be the things you will have in your hands will be so powerful and they'll be helpful for your development. I'll show you the practical example. And now how it works, before I show you live. We have Maven. I'm going to show you now the integration testing scenario. So in Maven, I'll go quickly and then we'll see the code. So I start Maven and I say, do the integration testing for me, for my Java application, which has the connection to the backend. The Maven gets all the details from so-called POM file. POM file is where Maven knows all the configuration. It's a build tool, so it gets configuration of what needs to be done from the POM file. Then it starts the Liquibase. So Maven starts Liquibase plugin. There's a plugin which helps Maven to start the Liquibase tool. Liquibase gets configuration from XML files of what needs to be done in a database. The database is empty when we start Maven. Every time we start integration testing, it's empty. Nothing is there. So we have a huge production database and nothing for integration testing. So we start empty. I mean, it's empty. So that's why Liquibase gets information from XML files which tell Liquibase what needs to be done in order to build the local database in the same form as it exists in production. So in that XML files, which know how to create the first table, the second, the third one, and then 50 different tables. So we have a full history of how our production database was started. So that's XML files. They know from the beginning of what needs to be done in order to build the database, which will look exactly like the production one. So we don't need to synchronize. We don't need to synchronize the production database and the test database. The test one is empty. It starts together with Maven. Then the Liquibase goes to this Postgres, temporary Postgres database, started right there, and updates the schema. It runs all the create table, update table, everything. So it builds the database for testing. And then it goes to Java, then it calls the Java files and asks, okay, now you can test. And then the Java goes to Postgres and does all the requests. And it will be perfectly fine because the database looks exactly like production. So we don't need to synchronize. We don't need to remember that every time we update the production, we need to somehow update our testing database, so our staging database or whatever. All we do is that we create a new file, which I'll show you now, and then the Liquibase will pick it up on the next integration cycle and create the database in the right format. That's what testing is about. That's how testing works. And at the same time, the same mechanism works for updating production database. In production, it works shorter. In production, we have this router tool, which, like I told you, starts a Docker container and runs all together inside the Docker container. It starts Maven. Maven starts Liquibase. Liquibase gets the same set of XML files. But what's interesting is that in that case, in production mode, the Liquibase doesn't need to upload all of them to production because most of them, except a few last ones, were already deployed there. So all Liquibase needs to do is update, so meaning running only the last one. So, getting the database in production up to date with the current situation, not rebuild it from scratch like we did for integration, but increment it. These files, I think they're called increments. So it goes to Postgres and uploads all the changes to Postgres. Enough of the theory, let's see it in action. Did you understand what I just, so I hope you did. So let me show you pieces of that. I'm not be able to, I'll try to show you everything. So let's look at the file. So like I told you, the database keeps the story of how the database, this is a real life application. It's in production. So this is the first file. This file is for the data. So Liquibase, it has a master file, which is quite simple. It just says include all the files from that directory. So every time you build a database, get all the files from that folder. In that folder, files are, these are the files which I have. So basically, I made 7 changes to that production database during the development of the project. That's how I started. I created the initial schema when everything was just empty. I was the author, it was 2 years ago, and I created, it was a small dating application, mostly like an experiment to show how things, like how technology works. So I created a number of tables. That was the first update. Then I created another one where I altered the table, I added some column, I updated some column, I altered the table. So I didn't touch the database in production. I created that file. And then the file number 3, and the file number 4, and until the file number 7. Today we'll create file number 8, and we will update the production database, and you will see how it works. So now let me show you how that table works in the Postgres. This is the production database. I just connected to it. It's production database on Heroku, and I run this query from the database changelog. So if I run it, I hope we have internet here, so let me run it. And I'm getting the data from the database, the Postgres on Heroku. Let's hope it's gonna work, please. Maybe the connection was dropped because I did it like this morning to check. Should work, huh? The whole thing? How do I do that? File. I think it will be more difficult. So let's just take a look at the content. Just trust me, I did that. That's live data. So you can see them, right? So there are 7 things, seven lines in this table. And there are dates, so you can see when these updates were executed. So it's 2014, so it's 3 years old. So that's production database, which was 7 times updated. And you see there's a number, the consecutive, the number of the change, of the increment, and then it's a status, executed. If it fails, it's gonna be, the status will be failed. And then there's a checksum, check summary, which is an indicator for Liquibase, so don't run it again. So if I, oh, you see, operation timed out. I'm not sure I know how to reconnect this thing. But we will need it, right? It's open source tool, I guess. The query, but not saved, okay. I guess we need to kill it. Let's try again. Because we'll need it to see how it will look after we update it. So basically, Liquibase keeps the history of updates inside the database itself. So this database change log is a table where all the changes are kept. And every time we send a new change, we send a new update there, then the Liquibase goes to that table in production and checks what was the last one. Because the Liquibase gets all these files together, creates and goes one by one. So it will, when we deploy it, will go file by file to the production and say, this one is already there. I'll show you logs now. This one is already there. This one is already there. And then it finds file number 8, and it says, oh, this one was not yet in the production. And it will run everything we will say in the file. So it will find what was the last position after, since the previous update, and will run it incrementally. You may ask whether it's possible to roll back. It's even possible to roll back. So when you design the file number 7, for example, 8 or whatever, then inside the file you can even say what to do if something needs to be rolled back. So you can define the increment, and then you can define how to jump back to the previous version. That's even more complex scenario. I was working in one project where we were using this Liquibase on really big production database, and we had hundreds of these updates files of increments. We were creating them every second day because we're a big team of programmers. And what's interesting, look at these files, they stay together with the source code. So I keep them together in the Git repository. So they stay together with Java code. They stay together with everything. So when the developer is creating something, the programmer, then that developer sends pull requests together with changes in the Java code and the new file for Liquibase, for the Postgres update. So the Java code comes together with the changes to the database. There's no need anymore for the developer to come to database administrator to talk and say, hey, I need some changes in the database, please make them. This is the request you need to run. Nothing at all. All you do is you provide the pull request together with your Java code and the changes to the Liquibase. And then we run the tool, and the tool brings everything to production. So nobody touches the database anymore. So let's see how it works. It's quite slow, but I guess we need to see it. Yeah, that's the Heroku. That's why it's slow. It's a pretty big list of databases there. See? They're not mine. They're just, you need to see the one without the X. Yeah, there you go. Yeah, this one. So let me see. How do I run the query here? Query tool, there you go. So let me make that request again to prove that database change log. There you go. So there are 7 changes which happened in production 3 years ago. Let me show how this is all designed in the POM file. I actually wrote an article 2.5 years ago explaining how this works, and so you can find them later on my blog, but still I'll show you the details here. This is a pretty big, huge POM file which instructs Maven what to do. I'll show you pieces of it. It will be interesting. First one, Liquibase configuration. This is the plugin for Liquibase. It's called Liquibase+Maven+Plugin. It's 3.2.2. Probably the version is quite old. Now the Liquibase is, I believe it's way younger. Way older now. But that's the version we have. We can see here, 3.2.2. Can I change the font here somehow? Yeah, there you go. See, 3.2.2. So this is the version of the Liquibase which made that update. So this is the tool, this is the plugin for Maven, which tells Maven how to run the Liquibase. So we configure it here, we instruct what the driver is, we give all the details, the URL, the username, the password. All this information comes from different sources. If we're running in production, to deploy stuff to production, then this configuration will come from the settings.xml for Maven, which we keep in production. If it's integration testing, then this information will be created on fly by Maven for the integration purposes. It's going to be test, test, test. The next piece which is interesting is the plugin for, this is not interesting, it's not for us. This is not for us. Yeah, PGXL. The next one is this one. Every time we start integration testing, every time we start Maven, we want to start the test Postgres. So we don't want to use any real database, any Postgres server for us in testing. We just start a server every time for us, for the Maven, which may sound a little bit crazy for you if you're working with some big pieces of data. And in most cases, people don't do that. In most people, most teams, most projects, they have some test server running Postgres, and they have production server, which also is running Postgres. What I'm suggesting is don't do that. Don't have a test server. Every time start a server in your build. That will make it more convenient and easier for developers to develop their stuff. They are decoupled from your test resources, from your test hardware. They can work on your laptop. They can run builds in parallel, because every time you build, the Postgres starts from scratch. It's a temporary version of the entire server. And this is the plugin which starts it. So first of all, we reserve a temporary TCP port and save that data in the configuration in the variable. So it's Postgres temporary TCP port, which is going to be used for Postgres. The second step is that we actually run that Postgres. This is the plugin name. It's an open source again. It's called PostgreSMaven+Plugin, version 0.2. Again, you definitely can see the more older version. And we tell that version how to start. You see, we have the test database name, test username, and the port is coming from the variable we just get. So we create a temporary port, and we give it to the server, and it starts. What it does, it initializes the database, it starts the server, and it creates the database, empty. So it creates an empty database by the name of test. What it does when it starts. And then when the integration testing is over, it also stops the database. So every time I start Maven, it starts the full server, runs my tests, deploys everything through Liquibase, the entire schema, runs my Java unit test, integration test, everything, and then shut down the server. So it destroys the server, shut down the process, and closes the TCP port. That's how it works. And then the Liquibase, so we call that Liquibase plugin and say update, and we call update. And we give the location of the test server. So we say, okay, there's a test port and the test database and the test username, just update the database. So when I say update, the Liquibase gets all these 8 files and deploys the entire thing to the test server. I'm talking about now integration testing scenario. What's next interesting is how this Postgres is actually deployed. It's quite a complex piece of software, and how this plugin works, it downloads the entire distribution, the entire package with the Postgres. Every time you start Maven, it gets this entire tar, the entire tar package, and unpackage it, unzip it, and prepares for start. If you look at this folder called target, this is the temporary folder Maven creates for each build, you can see where the Postgres is. Look, this is the real Postgres kind of server. So it has everything, like binary files, it has the documentation, and it has everything like a normal Postgres would have if you install it on the server. So for every Maven run, we get the full package from the internet. Well, it's not from internet, but we take it from Maven repository. We copy it here locally, then we unpack it and get it ready to start. And then we start it, and then we shut it down. And we start it here. That's the folder for the data. These are, if you're Postgres administrators, you will see that this is the real folder with real Postgres data, which integration tests will work against. So that's mostly what I wanted to show in Maven. This is interesting to see. This is the plugin which is unpacking, like I said, it gets the dependency, so-called dependency from Maven repository, Maven Central, and that's the version of Postgres 9.2.4. Again, it's probably older than what you have now, and it unpackages it and puts it to the directory I just showed you. Let's try to do it. How much time do we have? Half an hour. Oh, that's great. Okay, so let's try to make one more change to production and see how it works first in testing. So let's say I want to name my files with the prefix, so I put the number in front of the name of the file in order to sort them chronologically. So that's important. So it's important to keep files named by the prefix. If you name them randomly, then Liquibase will sort them by the name and will apply them in the wrong order, I believe, because this is the only way to sort files, because the ID of the file, the Liquibase doesn't sort by the ID, to my knowledge. So let's say we want to add one new column to the table human, and we're going to add, it's a dating application, so let's say we want to add the status of the marriage, married or not married. Let's call it marital status, XML. So we copy, we change the ID, it's going to be 8 number, it's going to be marital status, author is me, alter table human add column married. Let's make it Boolean. Boolean, default, I think it's like this, right? Will it work? Maybe yes, maybe no. Let's make a mistake. Let's do it this way. This one is really definitely wrong, right? So that's one, it's a wrong syntax for Postgres. Let's try it out. That's all I did. So let's say I'm a developer, I want one more column. Let's run it. Okay, let's do it this way. Let's delete it first and run the build. Let's go here. This is the build. Let's get the latest one and let's run this way. So we run all together, the full build, and we'll see how it works, and then we'll make a change. I'll show you now the log. I'll explain what's going on, step by step. It's not it's not so difficult. So don't be scared. It does many things. It runs Java tests, it runs integration tests, it does all the necessary pieces. A package is not enough, so let's do verify. It didn't run integration tests. Sorry. Who is familiar with Maven? Who are developers actually here? Okay, great, perfect. So it's just a normal build, a tool for building software. Quite popular. Now you will see. This code is open source. So this software which you can see, look what's happening. This is asking me as administrator of Mac, do I want to allow this new Postgres to allow incoming connections? I don't want that. I don't want anybody to connect to this temporary. Build success. Let's go through the log and see what happened here. We start, yeah, right there. So we reserved a new port for Postgres. It's 59316. That's going to be the port for Postgres. Then I'll show you just what's important. Then we just compiled Java code. Then we compiled unit tests. Then we executed unit tests. No Postgres at all now, at this point, because unit testing means no Postgres, no integration. It's just running Java against Java. Then we're copying Postgres to local repositories. So what we're doing is that we're getting this Postgres, the full package. Look, this is the name of the file. It's a quite big distribution 924 for OS 6. This is the file, big file, zip file, and we copy it here to the target folder. We just copied the entire file. The next step is what's important is that we initialize the database, init database. So this is the Maven plugin. So we didn't just copy, we also unpack that. So the Postgres is already ready. And then this plugin, it knows where the installation, the package is. So we makes init database. So we initialize the database. Look at the real log from the Postgres. We run, this is the location of our look. This is the executable file. So we execute, we started, and it says, okay, boom, we have the database up and running. Started Postgres, server started. We have real database now. And then create database, it silently created the database by the name test. And now we ask Liquibase, update. What Liquibase is doing, it says reading from database change log. It's empty because there's nothing there. First it says creating database history table with the name changelog because it doesn't exist there. The database is completely empty. Next, it says 001 initial schema, custom SQL executed. So it takes pieces of SQL queries from our files. 001, 2, 3, 4, 5, 6, 7. It says Liquibase successfully released lock. So first of all, it locks the database, so nobody can, so to prevent multiple Liquibases from running. So it locks the database, this locks the Liquibase files, and then it updated everything in a few seconds. And then we start integration testing. We have Postgres up and running, and we can connect to that Postgres and use the tables which are there. Look, we're doing some testing, we're dumping something, there's some temporary data, so we're working against that data. And then And then that's it, basically. And then we stop, yeah. And then we say, look, we stopped the database, server stopped, we shut down, we close the port, build success, everything is done. And now let's create that file. Let's make a new one. Like I said, marital status. If I make a mistake and make a file, add column married, default, I don't know, yes, not null, and then this is 8. There you go. Let's run it again. So now we are like saying, okay, we need a database which has 8 changes, not 7, but 8. We need a database which is more evolved, which has one more increment, which has a different column in the table. The status, married or not. And we made a mistake in the SQL. So now the build, I hope, will tell us that you guys just did something wrong. I cannot prepare the database for you. Boom. That's an error. So it says something like column yes doesn't exist. We did a mistake. We did it wrong. I don't actually know how to do it right. Let's try default true, I guess. No, probably by default false. Whatever. What's the default status for marriage? I don't know. Let's put false. Hopefully it's going to work. If it works, we're going to commit it to Git now, and we're going to deploy it to production. So now the integration test, well, I can write some Java code, we just don't have time. But believe me, if I write some Java code, which will do something with this new column, it's going to work. Because every time I run from now on, the column is there. Let's see what the Liquibase will say now. There you go. We have it. So all the integration tests are clean. The file is there. The database is ready for the next version. Let's commit it and push. Let's create a ticket in the... I need Chrome, I guess. Let's create a ticket which will say marital status. Let's add it to the human table. For some reason, I don't know. Well, it's a production project. I can remove it later, no problem. So the ticket number 27, so I'm saying git status, git add, git commit. Yeah, let's see. Git commit 27 married column. Git push origin master. So we push it to the real life master. Sorry for doing that without the pull request, but it's right there. We have it here, and now let's deploy it to production. I'm gonna run router and say release tag is the latest version I released was, let me check what was the latest version of this production application. So we did release 0.73. Let's release 0.708. It's a new status. What's going to happen now, it will take about 5-7 minutes. Now the router is a chatbot which starts a new Docker container on the server by that request. So it's a chatbot which talks to me in the GitHub ticket. So it will start now a Docker container for me. It will pull all the source code from this repository. It will run the same build we just did, and it will do one more thing, which I'll show you now. This is what it's going to be. This is the configuration for router. It's called .router.yml. It's a YAML file, which stays also together with the code. It's in the repository. It will do this. When I'm saying release, that's the full script router will run. We're not going to go through the script. It's quite cryptic. What it's doing here is it's deploying everything to Heroku and updating the database on Heroku. What we need here is this one line. So this is what it's going to do. This is the line we need. In this line, it will call Maven and say Liquibase update, and it will provide the configuration from the settings XML. So in the settings XML, there will be information for us that we are running in production. So forget the integration testing, don't touch integration testing database, but go to real production database and update our production database. So before deploying the real stuff, the real code to Heroku and rebuilding it there and deploying new version, we're gonna update Liquibase on the server. And we'll see the code now. Look, the router already gave us the response, said, okay, I'm working on that. It will finish that in like 5 minutes, and it will be done. Then I will go here, and I hope that we're gonna see one more line here, which will tell us that now our version is 008. So again, in one big production project I was working with a few years ago, we had hundreds of that files, and this table was quite huge, and it was so easy to see everything there. Who made the change, why that change was made, and there were quite complex changes. And what's interesting is that every time you run that, first of all, you run it locally. If it fails, like it failed in our case, it's gonna fail in production too. So you always can be sure that your local database, which you use for testing, for integration testing, is identical to what you have in production. You don't need to synchronize schemas anymore. You don't need to, like we had before we started using Liquibase, we had a technology so-called we were scrambling data, so-called. So we had a production database, and then the database administrators, they created a script for us to take that production database like every hour, download the entire database, which was quite huge, like copy the entire database. It was not Postgres, but MySQL, and then remove all the data from all the tables somehow, and then give it for testers, for developers to use. So it was like, every hour copy or every day copy, and then developers were able to test their code against that piece of database. It was a nightmare. It was difficult because there's only one copy there. There was only one testing database. In this scenario, every developer has its own database. You're working on one table, you want to change one table, go ahead, change your table, introduce new columns, drop the table, create table, doesn't matter, it's all in your branch. I'm working on something else. I create another branch, in that branch, I create a table, I drop the table, and then we submit pull requests. And then we decide which one goes live or which one goes to the master branch. But they're completely isolated. If you don't have that, if you have a test database, that's a wrong setup, because every time you will have conflicts. You won't be able to, to let many people work at the same time. Because when I'm a developer, I go to this test database, I drop the table, then everybody will stop working because I make a mistake. In this case, I make a mistake in my branch. If I drop the table, it doesn't build like it didn't build now, it's my fault. So I just rebuild it and that's it. Let me run it again. Maybe it's already there. No, it's still not there. It's still running. So that's, I think, a beautiful configuration to have. What problems you may have with that? What problems? I'll just tell you, in the future, you will definitely have issues. The first issue is that every time you use that approach, you will have problems with different platforms. So if I'm working on Mac and then another developer is working on Windows, then to run Maven on Mac and run Maven on Windows, it's different things. To start Postgres on Windows and start Postgres on Mac, it's different. So in POM, in Maven configuration file, we have, in this project, we have different configuration sections for profiles for different platforms. Look, this one is activated if you're running it on Mac. This one is activated if you're running it on Linux. This one goes if you run it on Windows. This one goes if you run it on something else. Well, Windows, Linux, and Mac, 3 platforms basically. So you will most probably need to configure it for 3 different cases, because installation of Postgres and starting Postgres is a little bit different in these 3 platforms. That's going to be the problem number 1. The problem number 2, which you definitely will see, and that's up to you how you solve that, if you want to configure your project for so-called green-blue deployments. Because in this case, there's no special configuration for that. Who knows what I'm talking about? I'm not sure I'm using the right name, but they're called, in some situations, they're called green-blue deployment. Meaning that if I go to production, if I deploy this create new column to production, but then I fail to deploy, because look at this file, what happens here is that first I update Liquibase, and then I put the code there. What if I put the code and then it crashes and I need to roll back the code? So how do I roll back the changes in the database? It's kind of difficult or sometimes impossible. If you, for example, drop the table or if you update the table and then the code doesn't work and you need to roll back and get back to the previous version, you can do it with the source code, no problem. You just jump back to the previous hashtag in Git and you have a previous code. In the database, it's not so easy, so you cannot roll back. That's why people use so-called green-blue deployments. They have two servers. The one is running in production, so you deploy everything there, all the code, and this one is like running in production, it works, and then they start a new server, they call this one green, and this is one blue, so you put all the code in here, you start it, you check it somehow with the scripts or manually. If it looks good, then you just change the DNS. You just change the DNS addresses, and this one becomes green, that one becomes blue, and you drop that one. And you just, remove it. It should be the virtual server. That's how normally deployment should work in production systems. So you don't just put everything to one server. Every time you have one configuration of everything, and then you start an identical copy of that configuration. You deploy everything there, and then you just swap them in the DNS. In the database, in case of the database, it's way more difficult to do. Because maybe some people can start the identical copy of the database, copy all the data there, and then deploy the new version, and then compare. If this one works, then you drop that database. But it's not so easy, because people still continue to update the previous database. So they still continue to make changes. So they go to your website, they do something, they pay with their credit cards. So there are some transactions are running there. You cannot just start something new and then wait for some time and put the traffic in there. So it's difficult. So you will have definitely some issues. Liquibase will help you to some extent, not completely, to my experience. So you will still need to do what to do manually, how you actually swap that environments, how do you start the new one, how you stop the previous one, how you kill the previous one. Liquibase, oops, there was some problem here. We don't have, that's something else here, sorry. I just changed something here and didn't test. Let me fail integration test. Disable that one. So I wasn't able to deploy for another problem, which is unrelated. Let's try again. So that's actually the log from Maven. I can see it here. I'll keep talking, I will try again. So yeah, you will definitely have that problem with this green-blue deployments. Well, we had that in a few projects. How we solve them, it's every time something manual. Every time you think from what we can do actually to, we have just 5 minutes. So let's hope that in that 5 minutes everything will happen. But trust me, we will definitely see the line number 8 here, and the Liquibase will update production database. I can show you the log of the build which I had yesterday. Maybe that will be enough to trust me on that issue. Demo release, this one, yeah. So I'll show you the production log of what happened in production. This is my log here. We need Liquibase. Everything else is not important. There you go. So we say Liquibase update. No, it's still test. I'll show you the piece of, yeah, this one. So this router inside Docker container, it called Liquibase update. It called that on production database. So it asked Liquibase to update. This is just some log for downloading, some dependencies. It's not important. I'll show you how it actually connected to Postgres on Heroku. And what did it say? Lower. Yeah, it's quite long. Sorry. Yeah, that's basically basically what happened. First of all, it acquired the log. The log acquired the Liquibase actually has two tables in the database. The one is called database change log, where all this history is kept. Another one is called database change log lock. So it's a table with just one column or one something. I guess it's like this. Let's see what's there. So it puts the lock there. Yeah, it says it is locked now. No, it's not locked. So now the Liquibase can actually put the lock there and do the manipulations with the database. So if you run the Liquibase from multiple servers and start to update your database at the same time, they will not have conflicts. So that's important for Liquibase. So first of all, it acquired the change log, and then it says reading from database change log, and then successfully release change log. So no changes are required. So I just did this, regular deployment, and no changes were required. So the Liquibase said nothing to do here, and successfully closed the connection to the Postgres. Today it has to actually make the update. What other problems you may have that are worth mentioning? You may have, with the rollback, definitely. You may have problems with, what people did. I just remember that mistake people did in the project when we just started, is that some programmers, let's say I give this project to like 10 different programmers, and some of them will do, because they don't understand, for example, how Liquibase works, they may locally in their computers, instead of creating the new file here, they may just copy that thing from here and inject it into the initial one of the existing files. So instead of incrementally creating new files and new files and new files, new developers who are not familiar with the tool, they will just go into one of that files, which exists there for 3 years, and just inject that code in here. And what's even worse sometimes, they don't inject it like this, they do it like that. So they just put it here. Sometimes they can do like this. Oh, that's a table, human. All right, let's put the merit status here. And they put the status right there. So that's a complete abuse of the entire technology. So we're not supposed to do that. So we never touch the files which were previously there. We don't change them. Because in that case, we completely messed the entire setup. You understand that? Because Liquibase will not understand what happened. The Liquibase will look at this, what Liquibase will complain about, it will look at this, it will calculate the checksum, check summary, will compare with the production, will say, hey, what's going on? The integration test will pass. Because for the integration, everything is fine, it's clean. Every time the database is clean. And the Liquibase will run everything, no problem. But then it will go to production. We will not understand what happened. We will merge the pull request. We will say, thank you very much. Your code works. Everything works. We run the integration test. Then we put it to production. And Liquibase complains like, hey, I just trying to deploy change set 001, but the checksum here and the checksum there, they're different. It's completely different SQL requests. And we will not be able to understand what's going on. And we roll back. We blame the developer. We talk. We explain. This is not how you're supposed to do that. Don't touch that file. And then they say, okay, sure, we're not going to touch it, and they do it again. So that's why we created some scripts. I remember that. We created scripts which, when you submit the code, when you actually run the build, they were checking somehow, I don't remember even how, but we built some instrument for that to prevent that from happening. But I remember that was a really difficult. We had 25 developers, and we had a few training. We trained them, we explained them. They were sure, yes, of course. And then all of a sudden, sometimes we're doing exactly the same. Just open the file and say, hey, that's a table human. We need one more column. Let's put it there. You put it there, the entire thing crashes. So that's so when you use Liquibase, we need to understand. It's like with Git. That's exactly the same. If you give all of us Git, and all of them will start using Git push force, and they will just push their branches, their master branch with the force push, it's going to be a hell, right? So it will become constant conflict in the main repository. So we need to teach everybody that use branches. Every time you do something, create your own branch and bring your branch to us, and we're going to merge, something like that. Or commit to master, but don't make forced pushes, because that will ruin everything. Did I break something here? No. Okay, let's see. It's still running. That's a good sign. Maybe it's already there. It's a live log. What other problems you may have? In the last few minutes, I'll tell you. Well, the naming. I said that already. So I named them correctly, 008, blah, blah, blah. But sometimes we had that already, that sometimes somebody may show up and say, and introduce a pull request with something like that. Like, hey, how about this? Marital status. Why do I need to put 008? Like, there's no, I mean, people don't understand sometimes. They just name the file the way they want, and Liquibase reorder them and put them in the wrong place. Then they run the build, and the Liquibase complains because, for example, alter table is not gonna work before initial schema. So first, we need to run initial schema, then we can update the table. So you cannot update the table and then create the table. We need perfect order of these files. In order to keep that files in order, you need to name them. That's the only way, to my knowledge, the only way to tell Liquibase what's first, what's next. So you just name them properly, and that's how it's gonna work. Sometimes people may, that was another problem we had. If there are many people working together, you start a branch, I start a branch. I put the name 008, you put the name 008. So we bring changes with exactly the same name, for example. And again, if your changes are touching my changes, there may be conflicts. So even though Git will not complain, for Git it's like 2 different files or 2 different names, the Git will merge them somehow. But semantically, on the level of the database, there's going to be conflict with the table. Again, people don't understand that. I create my branch, I name my file, everything builds in my branch, I give you the pull request, and then all of a sudden it gets rejected because it doesn't build after somebody else introduced some other changes. I don't know what's going on, it works for me, and then I need to merge the master into my branch, and then I see, okay, boom, now my database changes don't work. So that's another story where people will definitely definitely complain if they don't know what's going on. Liquibase, let's see the log, update. Yeah, it started that. Okay, we're close. Let's see what happened. Yeah, there you go. Look, this is the log from production. Liquibase acquired change log. It got everything from database change log. And then it says 008 marital status, custom SQL executed, ran successfully in 296 milliseconds. Let's check the production. We're lucky. Boom, 008 is right there. It just made, this is the status, the date is this day, executed, position number 8, that's the hashtag, SQL, everything is clean. So now, our table, our database has that column. It didn't have it before, it has that column from now on. Everybody knows who did that. I did that, that's the history. Why I did that? Because of that ticket. I can go back to the ticket, you can see where that file was introduced. It was introduced, look, it's successful. So Rulter said, I successfully did that, everything is clean. You can go back to the ticket and see why I did that. Because, well, it doesn't explain why, but in normal development, you will have a proper history of the code changes connected to your database changes. So that's a healthy way to maintain your database schema. Don't just go there with these admin tools. So if you develop your software properly, you never touch that piece of software for production. You don't even connect to production database. You don't do that. I mean, you may, but in extremely super critical situations. Normally, a database administrator is not supposed to do that. You don't touch production. All you do is you locally develop, create proper SQL updates, increments, and then deploy the whole thing to production and just be sure that it works and hope that it works. That's what I'm trying to do. Of course, sometimes you will need that, but that must be exceptions, not a normal situation. So ideally, never should have access to production, no passwords, no secrets. It has to be like a closed box, which is accessible only to Liquibase. That's what I wanted to show. Thank you very much.
Do we have any questions?
Yeah.
Okay, please.
We have a few minutes, probably. Go ahead. Yeah, that's a good, I repeat the question. So you're saying that actually, that's a good idea actually. Instead of like fighting with these differences in operating systems inside POM file, just recommend everybody to use Vagrant. This is your configuration, just start Vagrant, and inside Vagrant you run everything. Or if you're in production, start Docker and run everything there. It may work, but it's an extra layer which some programmers may complain about. Me, for example, I like Vagrant, I tried it like a few times, but it definitely slows you down. It's not as fast as you can run natively. So we found out, like I personally recommend to configure POM to make it executable on all platforms. It's possible. If it's, I would suggest to use Vagrant only if it's not possible to do what I'm saying, to do it, you know, compatible with all platforms. In this case, in case of Postgres, it's possible. In case of MySQL, it's possible. In case of Oracle, for example, I doubt it's possible. Or maybe it's not possible. In case of some other databases, maybe not. Postgres and MySQL is two databases. I was perfectly running on Windows, Linux, and Mac. But again, Vagrant and Docker are great technologies. Docker is great, is faster, but it's not, for example, I'm not sure about the status on Windows. People say it works, but I'm not sure it works actually like entirely as good as it works on Linux, but on so-so. On Mac, it's also so-so. I mean, you need to install some virtual machine layer. It slows you down. Everything is slow. It's more a hassle than actually a good solution. So if my Maven, I showed you, it works out of the box. I just run it, Postgres starts. I don't need any extra layer on my machine. Yeah.
How long time your integration test is running? Because we have some integration tests in which goes to database, but it works really slowly.
Mm-hmm. Well, you just saw how it works. It's really fast, but the application is really small in this case. Yeah, it's just micro application. In a real project, in one like really big production projects, I can tell that we had tests, the longest, we had like hundreds of tests, and the size of the database on production databases was really huge. I mean huge, like millions of records in some tables, or tens of millions. And the maximum time we had like 35 minutes, 40 minutes for the full package, for the full build, which is extremely slow. It's bad, it's not good. If you have 40 minutes for the full cycle, it's a problem. It means that your project is just too big. It's not about the size of the data. It means that you're putting too much functionality in one big monolithic project. Instead, break it down into 1, 2, 3 microservices. That's my recommendation. Because 40 minutes, nobody gonna like you as an administrator, as an architect of that project. No developer is gonna like you. Because if I need to run the full thing for 40 minutes in each branch I'm working on, I'm gonna hate that project. It has to be fast, it has to be, but integration tests must be there. And they should not be that slow. In that case, they're not slow because Postgres starts empty. It's not that big, it's not that slow. It starts in a second or less. And then all the tests, they work with really primitive data in the process. You just saw how long it took. Look, the entire build here takes 33 seconds. If it's including all the integration tests and everything. But of course, there are just 4 integration tests or something.
So Igor, I'm sorry.
Yeah, we're gonna go.
We're gonna go. So, хочу напомнить, что всем